So right now we're going to talk about absolute value equations. Let's look at just kind of some basic situations first, and then write some definitions down. And I'm going to number these by the situation I'm going to be dealing with. So situation 1, example of this. I have the absolute value of x equals 5. So let me think about that. What are the answers I could have? What could x be to make that true? I mean, it could be 5. Obviously, if I put in the absolute value of 5, it's 5. But what else? There's something else. Negative 5. Because the absolute value of negative 5 is 5. So it works that both of those x's work for that equation. How about situation 2? The absolute value of x equals negative 3. Is there anything I can put in for x, take the absolute value, and get negative 3? There's not. This has no solution. Because, remember absolute values, no matter what you plug in, you're going to get a positive as the answer. Now, how about the last one? If I had the absolute value of x equals the absolute value of negative 2. So, what could I put in for x to make this work? I mean, if I kind of over to the side, do a little simplifying, this is the same as absolute value of x equals 2, because the absolute value of negative 2 is 2. So kind of like the first one, my answers are going to be a positive 2 and a negative 2. So, kind of generally, it looks like with a lot of these we're going to have two answers. Or if we have a negative on the right side of the equation in this case, then it could be no solution. So let's write some definitions for these three situations. So these are kind of the absolute value equation rules. But hopefully once you do a couple, they'll start to make sense. Absolute value equation rules. So for situation 1, if the absolute value, I'm going to use a big X here because it could be not just a variable x, but it could be something like 2x plus 1 or multiple things in there. So if we have the absolute value of x equals little a, and a is positive, then we solve x equals positive a or x equals negative a. Kind of like with the first one, we got x equals positive 5 or x equals negative 5. Both of those answers worked. For situation 2, generally speaking, if x, absolute value of x, equals equals a, if the absolute value of x equals a, and a is negative, then there is no solution. There's no solution. And I can't remember if I did it before, but you could use that no solution symbol. And then the last situation, if the absolute value of x equals the absolute value of y, so if you have two algebraic expressions and absolute values equal to each other, then we're going to solve x equaling y or x equaling negative y. So now the key with all of these, though, let me pull a star. So that's kind of the rules we're going to follow. The key with all of these is isolate the absolute value part first of the equation. Isolate the absolute value part of the equation first. We're always going to have to do that. So, for our first example, let's say we have the absolute value of 2y minus 5 equals 3. So, right away, so this is situation 1, we've got the absolute value of something, and then on the right side it's a positive real number. So I'm going to solve two equations, 2y minus 5 equals 3, or 2y minus 5 equals negative 3. So when I drop those absolute value symbols, I'm just sending it equals to the positive and the negative. And now I solve each of them. Add 5 to both sides, so 2y equals 8. And I might as well do the other one because it's going to be the same steps. Add 5 to both sides, 2y equals 2. In each case, divide both sides by 2. So y equals 4 or y equals 1. And now I can plug it in, test them both. Maybe I'll kind of just do it real quick here, talking through it. 2 times 4 is 8. 8 minus 5 is 3. Absolute value of 3 is 3. If I plugged in 1, 2 times 1 is 2. 2 minus 5 is negative 3. Absolute value of negative 3 is positive 3. So those both work. How about this one? The let's see, 3 times the absolute value of x plus 2 and the absolute value plus 10 equals 5. Okay, now here's one where we have to do a little work first to isolate the absolute value part. So first, I'm going to subtract 10. So I have 3 absolute value of x plus 2 equals negative 5. Now I'm going to divide both sides by 3. Absolute value of x plus 2 equals negative 5/3. Okay, now this fits into my having the absolute value isolated. So, which situation is this? This is number 2. Can I in any way do something to the left side, take the absolute value, and get a negative 5/3? It's not possible. I can't have a negative once I take the absolute value. So no solution. No solution to this one. So basically, you know, when you have the absolute value and on the other side we have a negative value, no solution automatically. Okay, let's do one more. How about the absolute value of x plus 2 equals the absolute value of 4 minus x. Okay, so here I have absolute values on both sides. So I'm going to take one of my situations is I'm just dropping the absolute value on both sides. I'm going to set the x plus 2 equal to the positive of 4 minus x. Or I'm going to set the x plus 2 equal to the negative of 4 minus x. Now notice it's important to use parentheses because that whole side on the right needs to be negative. So I'm going to have to distribute that minus sign, or that negative sign. So let's do the left side first. I'm going to add x to both sides first. Those x's together. So 2x plus 2 equals 4. Subtract 2. 2x equals 2. Divide by 2, x equals 1. Okay, so there's one answer. Okay, now on the other side, let me distribute this minus sign first. A minus 4 plus x. Let's get that minus to both parts. So minus 4 plus x. Now I'm going to subtract x on both sides. And 2 equals negative 4. Okay, that part doesn't have a solution. Just like regular solving equations, when the x's drop out and you get two numbers that are not the same equal to each other, no solution. So I only have one answer. Only x equals 1 is true for this one. So every once in a while that might happen, that with an absolute value equation problem you might have just one answer. Typically it's going to be 2. if it's not the no solution situation, but in this case, it's only 1. And let's check that. If I put in 1, 1 plus 2 is 3, absolute value of 3, and then on the right side, 4 minus 1, that's also 3. Absolute value of 3 is 3. So it checks out.